Hello students, this is Dr. Anita Raj, your chemistry mentor, welcoming you for an important session in aldehydes, ketones and carboxylic acid. In this session, we shall see the different types of tests to distinguish aldehydes from ketones. Okay, so we shall see the tests for distinguishing these aldehydes and ketones, students. The first test is Fehling's test. Okay, actually this Fehling's test is answered only by aldehydes and not by ketones. Okay, so let us see what is Fehling's reagent first. Actually, this Fehling's reagent is of it comprises of two solutions, Fehling solution A and Fehling solution B. Okay. So what is Fehling solution A? It is nothing but it is aqueous copper sulfate. Okay, aqueous copper sulfate solution, and Fehling's B solution is alkaline sodium potassium tartrate. Okay, alkaline sodium potassium tartrate, and it's also having another name, that's Rochelle salt. Okay, or O C Helle. Okay, so this is the other name for this alkaline sodium potassium tartrate, that is Felix B solution, right? So actually what happens is these two solutions are mixed in equal amount before testing. Okay, we should take both solutions, Felix solution A and Felix solution B. Both should be taken in equal amount and that should be mixed together. And to this solution, Felix reagent, will be adding the aldehyde to be tested. Okay. Now, when after adding this aldehyde to these two solutions, we heat this aldehyde. Okay. On heating an aldehyde with Fehling solution, a reddish brown precipitate is obtained. Okay. When you are heating aldehyde with this Fehling solution, a reddish brown precipitate will be obtained. Okay. Let us see what's going on here. Actually, this is acetaldehyde CH3CHO. So this is acetaldehyde, okay, and then this is what is the substance? So actually, copper sulfate, alkaline potassium tartrate, both these together mixed, is it not? So this is a Fehling solution, okay. This mixture is a Fehling solution, and when this acetaldehyde is treated with this Fehling solution, this acetaldehyde or the aldehydes are oxidized to corresponding carboxylate. Okay, they are oxidized to corresponding carboxylate. So this acetaldehyde will be converted to a carboxylate, that is CH3COO minus. Okay, along with this we will be getting Cu2O, which will be having a red color. Okay, and this will be a red color precipitate. Okay, this will be a red color precipitate, and we'll be getting 3 molecules of water. So this is what happening. So when you add this aldehyde to the Fehling solution and when you heat this aldehyde will be getting converted to a carboxylate anion and will be getting a red color precipitate. This is this is what happening when you are adding aldehyde. But when you are adding ketone to this Fehling solution, this reaction will not take place. That is, this ketone will not be reacting with the Fehling solution. So this is a very good test. This Fehling test is a good test to distinguish aldehydes from ketones. Understood, students? So the next test is the Tollen's test, and this Tollen's test is also answered only by aldehydes and not by ketones. Okay. So Fehling's test and Tollen's test are the best tests to distinguish aldehydes from ketones. Okay. So what do you mean by Tollen's reagent? This ammoniacal silver nitrate solution is otherwise called as Tollen's reagent. Ammoniacal silver nitrate. Understood, students? So when you are warming an aldehyde with a freshly prepared Tollen's reagent, a bright silver mirror is produced due to the formation of silver metal. Understood? So when you are heating this aldehyde with a freshly prepared Tollen's reagent, what is Tollen's reagent? It is ammoniacal silver nitrate solution. Okay. When you are mixing this aldehyde with this Tollen's reagent and when you are warming it, it forms a bright silver mirror. Why we are getting bright silver mirror? Due to the formation of a silver metal. Actually, this reaction occurs in alkaline medium. Okay, only in the presence of alkaline medium this reaction takes place. Okay, so what is this Tollen's reagent? Actually, this is the Tollen's reagent. Okay, Tollen's. Okay, Tollen's reagent. So we have taken aldehyde, that is acetaldehyde, and acetaldehyde is treated with Tollen's reagent, and when it is warmed in the presence of an alkaline medium, we get this type of product, that is CH3. Again, these aldehydes are oxidized to corresponding carboxylate ion. Okay, so CH3, COO. Okay, since we are having this ammonia, okay, CNH3, we get the salt, that is CH3 and COO. NH4. Okay, and to this we'll be getting silver metal. So this silver metal is responsible for the formation of the bright silver mirror. Okay, when you are adding this tolerance reagent, understood? So along with this, you'll get the product ammonia. Okay, NH3 will also be produced. Okay, so ammonia plus water molecule. Okay, so plus water molecule. So this is responsible. This silver is responsible for the formation of the bright silver mirror when aldehyde is added to tolerance reagent. Understood, student? See here, this ketone will not be undergoing this type of reaction. No reaction will be seen when ketone is added to tolerance reagent. Understood, students? The next test is by reduction. Okay. See, aldehydes and ketones both get reduced. So when aldehydes and ketones are reduced to primary and secondary alcohols respectively by lithium aluminum hydride. See, when aldehydes and ketones are treated with lithium aluminum hydride and when it is hydrogenated, this aldehydes and ketones will be undergoing reduction. So aldehydes will be forming, see this aldehydes will be forming primary alcohol and this ketones will be forming secondary alcohol. Thus we can differentiate both aldehydes and ketones by reduction. Okay. So let us see what is happening here. See, I have taken acetaldehyde CH3CHO and it is reduced in the presence of lithium aluminum hydride. Okay, lithium aluminum hydride. Okay, so when it is reduced, it forms ethanol CH3 CH2 OH. Okay, CH3 CH2 OH ethanol. See here, I'm just to split and show you CH3 C double bond OH. Okay, so just see when you are adding hydrogen here, this hydrogen H2, I'm splitting like this. Now one of the hydrogen gets added up to this and another hydrogen gets added up to this. Okay, so you'll be getting this product. Understood? CH3 CH2 OH. Understood, students? So this is what happening. And now I have taken a ketone, that is acetone here, CH3CO CH3. So let us see what happens when you are adding lithium aluminum hydride. Okay, lithium aluminum hydride, and it is reduced. See here, hydrogen I am splitting like this. Okay, so what happens to this? One of the hydrogen gets added up to this carbon and another hydrogen gets added up to this oxygen. So we get a product like this CH3, CH, OH, CH3. Okay. So this is propane to all. Propane to all. Okay. See here, when you're reducing this acetaldehyde or aldehyde, you're getting a primary alcohol, and when you're reducing a ketone, you're getting a secondary alcohol because this OH group is attached to the secondary carbon. When you call a carbon as a secondary carbon, when this carbon is attached to two more carbon atoms. When the functional group is attached to a carbon which is attached to two more carbon atoms, we call that carbon as secondary carbon and that product as secondary product. Okay, secondary alcohol. Understood, students? So this is what happening during reduction. Now the next test is by polymerization. See, aldehydes polymerizes easily, but ketones do not undergo polymerization. Yes, aldehydes, for example, when you are taking formaldehyde, when formaldehyde is treated with phenol, it undergoes polymerization in the presence of sodium hydroxide and it forms bakelite. Bakelite is a polymer, okay? Whereas this ketone, it does not undergo polymerization. Thus, we can differentiate aldehydes from ketones, okay? By polymerization technique, by reduction technique, by Fehling solution, and also by a tolerance reagent. Understood, students? Well, fine, students, you might have understood what I have taught today. Let me meet you with another important topic in my next video. Until then, it's Dr. Anita Raj signing off from you. Thanks for watching.